Alright, we're going to try this again. My name's Trevor Grant, and I am giving this demo video of my submission for the IoT Watson IoT AI-a-thon. I am a open source evangelist slash, I guess, data scientist, whatever, extraordinaire, living in Chicago. And the spirit of this demo was I started off wanting to give data scientists a way that they could bring their own models to Watson IoT Analytics. There's been some work on this, but I think that it needed to be blown open a lot more. And so I started with that, but then I quickly realized that we run in batch, and 5-minute is about the most frequent that you can do updates. And as we're moving into the artificial intelligence of things, and that's AI deployed to IoT, that 5-minute batch is just too slow. And so I broadened my scope out of ways to create a real-time analytics system that could mount models in real time and serve and bring your own model. A data scientist could bring their own model. The idea there being that, again, a client data scientist will always know more than about their data than us as system engineers. And even if that's not the case and the client doesn't have the data scientist to build their own models, at least giving global business services a chance to come in and rapidly deploy models on hardware is, I think, a win as well. So this will be the live demo. You'll see this link here soon. Here is the link. However, this whole application is cloud native, and IBM's Kubernetes is a little expensive, so it will not always be on. If you want to see it live, just give me a call and I can fire it back up for you, no problem. But this is a cloud native demo. This is Thursday. I've got tomorrow and the weekend that I'm going to probably fill in. So if you see these things like prompts and buzzwords, that's me giving myself notes. But the data source we're using here, since this is live in real time, is the City of Chicago's Divvy Bike Data Program, which it's a shared rental bikes, and each station, there's about 600 stations, 580 stations, and each station every few seconds emits a record saying, and it looks like this: station ID, how many bikes are available, how many bikes are broken, docks available, if it's, everything up and running, is it taking bikes right now, and, the epoch of the last report. And so we've got that data flowing in. That being said, well, let's just jump over to the architecture, and maybe that's going to make a little more sense instead of talking about it. So purple means things that exist. Case in point, the Divvy Bike program. Green are things that I built. Blue are things that I was going to build, but kind of ran out of time. So let's just follow the data as it comes in. It's emitted from the Divvy program, and we have a Watson IoTP shim that is pumping it into Watson IoTP. I had written a functionality in my React app to do this, but I haven't quite got it working yet. So to prove that I am actually generating data, here it is, pushing data into, publishing events into the Watson IoT platform. So data is pushed in, which all that really means is going to MQTT over the brokers, and then it's picked up by our Flink stream. And what Flink is doing is doing something called sliding windows. So that means in this case that every 30 seconds, the last 2 minutes of data are emitted. So that, and that's very configurable. You can make that the last 24 hours. You make it the last, half an hour. And that's important because different use cases are going to have different necessities of what kind of windows they're going to need. Maybe you need multiple windows. And so it's like a sliding, sliding averages, sliding minimum, sliding max, sum of squared differences, standard deviation, count, etc., etc. And as those records go through, they call a endpoint that returns a list of other endpoints. And to show you exactly what that means, Here's the OpenWIS code that's doing it. I was hoping to make a way that you could just add your own, but I didn't. Ideally, this would hit off of some sort of database on the back end that keeps a list of all the endpoints that need to be hit. But again, this is a minimum viable product, so for the moment, it's just a hard-coded list that gets returned, and I only have one model, and that's a simple anomaly detection. And we'll dig into that in a minute, but for the moment, note that this list of endpoints comes back. Now, each record or each analytics emission, so the min, max, sum, average, standard deviation, blah, 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 from the last 120-second window, will go to each endpoint. And the way I have it currently set up is each record that comes through is joined with the most recent window, and that is what's sent to each endpoint. So for example, if this is the most recent record, then it says, okay, there's 9 bytes available and 0 bytes disabled. It sends the whole record actually, but then it I lost it. But let's say there's 9 bytes available, but the average bytes available are 8. So it's sending the most recent analytics, and it's also sending that record to each. Again, all very highly configurable, but that's how it's running at the moment. It then syncs those that and the model result that comes back into Elasticsearch at the moment. Ideally, cloud object storage would be better for long term. And going back to that artificial intelligence of things, you want to have a way for the system to actually make actions and put commands back in the pipeline, and that could be a thing too. Again, very, very easily. An example might be if one machine's running a little hot, that's not a big deal. But if all the machines are running like 15 degrees hot, maybe we need to check the air compressor or the air conditioner or something along those lines. So the idea though is that you have this central state of the world, and that you can see more things when you see everything that you can't see when you're looking at machine 1 has reached some critical threshold where it's too hot, therefore we shut machine 1 down. No, we want to be looking at the system as a whole, and that's where the artificial intelligence of things, that buzzword, comes in. So moving on, what I was able to come up with was React dashboard. I'm still learning React, so this isn't the fanciest of dashboards, and it probably took me more time than it should have. But without further ado, here we go. So this is the shim I was working on. Again, it's not working, but we already saw that I'm running it in Python just on my IDE, and it's getting the job done. And so here's the Flink job, and it's been running for a little while now. So the data comes in, the custom source is the MQTT broker, and then here's the sliding window that runs all the analytics, and then it munges back together the most recent analytics and the records coming through. And so the new records coming through will probably be getting tied to the analytics of the last window, if that makes sense. And then over here, we've got what is in essence, every 30 seconds, it says go ping that endpoint server and get the updated list of analytics, or of endpoints, and then every record that comes through, fire that to every endpoint. Now it's all highly configurable. You could say that you only want assembly line machines going to these models, and you only want pizza makers going to these models, and you only want truck gas gauges going to those models. And that all can be set up, but for minimum viable product for the hackathon, this is what we have. What else we have is I was hoping to do some really, really cool React apps. Unfortunately, that was not the case, and oh well. So here we have our gauges. So this is the anomaly detection. Let's talk about each of these in turn. I'm going to start out of order. This is the bikes at each station. There's only 3 stations we're watching right now. The IBM IoT platform Lite. I kept blowing out my data. I kept pushing too much data through it, so we had to buckle it down from 500 stations to 3 stations. It's much safer. But then what we're able to do is we're looking at, over the last 120 seconds, what is the average number of bikes that were available. So we see that there was probably one coming back here, and then someone checked one out. or that there's just some other bugs in this program that I haven't quite figured out yet. This is the average number of bikes available at all the stations in our whatever. Not that that's a super useful metric, but that this is an example of how the analytics work. And then we have the model serving. So let's go look at the model serving real quick, and our simple anomaly model and what exactly it is that does. So I'm not sure if you can see this, but the gist of it is it takes these records in, and it takes the analytics, and it says, all right, for every analytic piece, so number of bikes available, e-bikes available, docks disabled, for every one of those analytics, it looks at the average from the last sliding window analytic period and the standard deviation, and if the current record's value is more than one standard deviation above the average, then it's danger high. If it's more than one standard deviation below, it's danger low. Otherwise, it's all as well. Now, as you would imagine in this, everything's pretty much always all as well, but if it's all as well for a while, your standard deviation is probably 0, and so any movement becomes all as a danger high, which I'm pretty sure this is. I'd have to, let's see if we can blow this up. Yes, danger high. So that's what that is. The point being, though, is we can see that we are getting service from our model serving, which is cool. Now, I believe that the point of this AI-a-thon was to write some cool new model, and you're probably thinking, like, this isn't the coolest of new models. Oh, also the time, you might have just seen that that these numbers are changing. It's last 30 minutes, so that's what's going on there. At any rate, you might be thinking, well, this isn't a particularly exciting AI model, and I'd be the first one to agree with you. What it is, though, is a platform for developing some really cool AI models and really letting clients who understand and know their data bring their own AI models. And if we go back to this arch diagram, well, I'm doing this in OpenWhisk, and that can be a kind of scary thing for some people to work with. You also have endpoint serving in Watson machine learning. You have people, for whatever reason, keep serving models in Flask, and I think that's an anti-pattern, but it's a thing you can do. And so wherever you're comfortable serving your models is where you can. If you want to get into Selden Core, you've got a lot of built-in A/B testing and multi-arm bandit testing. There's a lot of model serving. There's a proliferation, I would say, nearly as bad as the proliferation of data science tools is the proliferation of model serving tools. We're starting to see that. But what we're doing with this system is allowing data scientists to choose their own model serving tool and go with it from there. The other really important thing about this that I want to point out is this entire application is cloud native. The reason why you will not always be able to hit this endpoint is Kubernetes is kind of expensive on IBM. So when I'm not running this demo for people, I will turn it down. It's pretty easy for me to fire back up. I can usually do it in about an hour or so, and most of that is just waiting for the Kubernetes cluster to come up. But it's a quick thing to do, and it's really not that bad of a thing at all. And it could be optimized as well. Just to prove that I am not blowing smoke, this is my Kubernetes cluster, here's my Kibana, my Elasticsearch, my Flink Job Manager, and my front end was a not particularly cleverly named name for my React app, which is serving. So, that being said, I really hope you can you reach out and talk. I think there's a lot of interesting and fun nuggets here and things to think about. And I would love to get some ideas, some feedback, if some of this can be worked into a product. I think it all definitely is very close to being productizable, but the idea that we're just going to rip out IoT analytics service and replace it with this tomorrow, I feel like would be a bit naive on my part. But again, hopefully useful pieces can be drawn out, and if that's the case, I look forward to helping anyone in any way do it. Please also read the README. I gave a big high level. There we get into a lot more of the fancy dance in here, and I'm going to be writing more tomorrow as well. Another interesting piece of this is, in addition to the artificial intelligence of things, which is admittedly very buzzwordy, This system also allows for not only lambda style architecture, which I'm guessing all the other submissions are, and that's where you train offline and you serve online, but it also allows for kappa style machine learning models where they're both trained and served online. And so that's a thing. There's a few other things in there too. I only briefly touched on A/B testing and canary testing. When you get into online machine learning models, things get real hairy real fast. But the point is that this is a system that would support it, and even if we don't go with this system, it's probably something that we should start thinking about, because this is the future of AI and IoT. So without further ado, thanks very much, vote for me, and have a great day.